Supplemental math videos from Circle Christian School.
Geometry Chapter 2 Review. Use the review exercises to practice for the test. Doing the odds are very helpful because they're in the answer key. Also remember to take a look at the vocabulary and what the vocabulary means. It doesn't hurt to make your own little vocabulary cards. Practice, priming your brain, are all the ways that make for a successful student. We began with describing different types of patterns. With numbers, you can always look for the alter ego. What kind of ratio, that is it being times by a same number? Or you can see if there's a common difference by going 21 take away 3 equals what? 147 take away 21. If it's a big spread, you may want to look a little bit more toward something being multiplied. To make a conjecture is to make a statement. It is the hypothesis. A counterexample is any example that proves otherwise. For instance, if the quotient of the two numbers is positive, then the two numbers must be positive. What's important here is to see what is being stated to begin with. You have to know some key words like quotient. Quotient means we're doing division. Product, we're multiplying. Sum, we're adding. Difference, we're subtracting. Is positive, so it kind of gives you an adjective here as to what the words are doing. A counterexample in this case would be, hey, if we have negative integers being divided, it also gives us a positive number. When analyzing conditional statements, that is, if this, then that, our positives begin with a conditional statement, a statement that is true. We call it if P, then Q. Converse means we're just working backwards. The then becomes the if, and the if becomes the then. The negatives are inverse and contrapositives. If not P, then not Q. And the contrapositive just reverses that. If not Q, then P. There are generally two types of reasoning. The first one is being deductive. That is, because something happens and there's a result and quite possibly eliminates some possibilities, that's deductive. Think of a detective. Inductive means that it just happens over and over and over again the same way every time. If two angles have the same measure, then they're congruent. Theorem 2.2, the angle congruency theorem. When we're writing our measurements, that is, it has an M in front of the angle here, we're actually talking about measurement, actual size. We always use an equal sign for that. And then when we want to move on to saying that two shapes are the same size, we use the congruency sign. Postulates and diagrams. Let's draw a plane with a line that intersects at one point. What's key here is to note, go through the problem slowly. You can do some little blockouts here to see exactly what's being asked of us. A plane, a line, intersects, one point. All right. Now generally to draw a plane, what we'll do is give it some dimension. A plane is any shape that has at least 3 non-collinear points. All right, we need a line that intersects at just one point. So I'm going to make a point on the plane. And remember, anything that we could not see for real is dotted behind the shape. I'm going to call this line L, and we'll call this plane M. Next one, a straight angle CDE bisected by ray DK. Straight angle. Okay, we have four types of angles. We have the right angle, 90 degrees, an acute angle, which is smaller than 90 degrees, an obtuse angle, which is bigger than 90 degrees, and then we have a straight angle. A straight angle is 180 degrees. Okay, so we know that we have to start with the straight line. There's evidently 3 points on the straight line. And it's going to go through D, or D is basically going to be the vertex here. And it ends up at E. All right, it is being bisected by a ray. Bisect means that we're actually going to cut it equally in half. And because it was a 180-degree angle, cutting it at half means that both sides are going to be 90 degrees. 90 degrees equals a right angle. Our beginning proofs were using the properties from algebra. Solve 3x plus 2 times 2x plus 9 equals negative 10. All right, we always start with defense of equality. And what's a little bit different here is that we're going to give reasons for each step. All right, the first thing that we always do with the problem, step 1, distribute and combine like terms. Distributing is that property of multiplication over addition and subtraction. 3x plus 4x plus 18 equals the negative 10. And that's the distributive property. Next, what we're going to do is we need to combine some like terms. We have x's, and we can combine any variables together as long as they have same letter, same power. So 3x plus 4x equals 7x plus 18 equals the negative 10. We use the addition property. All right, we have to get the x all by itself, so I'm going to take away the 18. I like to do mine vertically. And that's going to give us a 7x. The 18's gone. And a negative 28. That was the subtraction property. All right, now we're going to divide out the 7's. And x is going to equal a negative 4. And we use the division property. Statement, then a reason. And remember, every proof always begins with what you were given. Proving statements about segments and angles is much like when we use algebra. The only difference is that here we are going to give reasons of either a definition in geometry, a postulate from geometry, a property in geometry, and maybe a theorem that has already been done before. All right, we're given that AB is a line segment, and what we need to do is prove AB is congruent to segment AB. All right, the first part's always the easiest because it's what we have to prove. Oh, I'm sorry. It's always been what we're given. Thinking way far ahead here. AB is a line segment. We also know that we have to have in our proof what we're going to prove. So you can put that way down toward the bottom, leave yourself some nice space. And of course, we don't know the reason. We don't know which statement it's going to be. Okay, so our second reason is going to be AB is the length of segment AB. From A to B is the length of segment AB. Well, everything has measure, does it not? So it's actually the ruler postulate. Our first postulate, the ruler postulate. All right, well, because AB has measure, we know that that measure equals that measure. Now notice there is something a little bit different here. We don't have a line over the top. And with segments, that means we're talking about actual length size on a ruler. And in this case, it's the reflexive property. Same thing equals same thing. So therefore, AB is congruent to AB. Definition of congruent segments. And you've done a proof. As we go along in geometry here, we're going to prove more and more statements about angles or segments. The first thing that you do with every proof is you always put down, you always draw a picture. Okay, the second thing you do is you always put down what you've been given and what you have to prove. We've been given that angle 5 is congruent to angle 6. That's going to be the third thing that we're going to do is let's mark it up. Label the picture. We need to prove that angle 4 is congruent to angle 7. Either put question marks or some sort of highlighter as to what you have to prove. It helps you move along the way of the proof. Next, we're going to start doing the proof. All right, let's always start with a given. So angle 5 is congruent to angle 6. Always the easiest part because that's what we've been given. And we know we have to work our way down toward proving that angle 4 is congruent to angle 7. All right, so we have the two angles. Let me see here. We have some intersecting lines. Okay, intersecting lines, and it gives us these angles, and these angles seem to be across from each other. Well, all right, let's see. Angle 5 is congruent to angle 4. Very good. And that's because vertical angles are congruent. So the vertical angle postulate, postulate number 12. The last one that you have to know. And we also know that angle 6 is congruent to angle 7 because they're vertical angles. Very good. Okay. Well, that's going to leave us at, let's see, angle 4 is congruent to angle 5 is congruent to angle 6. Forgot my little angle there. Is congruent to angle 7. All right. Congruent angles are all congruent. Theorem 2.2, the congruency of angles. And therefore, angle 4 is congruent to angle 7. When we move from one place and had to go through a couple of congruent things to get to the end, it's always transitive. And you have done another proof. Okay, hope this helps you a little bit on your way while studying for your Chapter 2 test.